What are deleted files? Deleted files can occur in a couple of ways. Number one, the user can create a file, and then later they use the delete key or right-click and delete the file. Or the file could be created by the operating system itself. This is the case with temporary internet files or temporary files that are created as software is loaded or run. The system itself will create the file and then go back and delete it to free up space. Unbeknownst to a lot of people, these files, even though they're deleted, can be recovered, at least most of the time. There are a few ways where you can permanently delete a file, but because of the efficiency of a computer and the ease of use of a user, this is not always the case. Most files can be recovered. For recovering erased files, yes, even you can understand this special form of black magic. What we're going to do in the following slides is show you in a DOS operating environment or a FAT table on the proper technique and what really goes into recovering erased files. This is important to you because multimedia cards, thumb drives, items like that today still use the FAT table as a means of recording files onto the media. And when they are erased, as you will see and learn, it is actually pretty easy to recover the file. Now there are some techniques that can permanently delete the file and we can't recover. But because of the ease of use and the ease of a user using a application, this rarely happens. What you see here is, number one, a root directory. You'll have a program name or a file name, how big the file is, and what is the starting cluster for that file. That starting cluster also refers to the FAT table on the right-hand side. As you can see in our representation here, the green squares on the bottom of each light green square is the cluster number or representation in the FAT table. So as we look across the top line, you'll see 2, 3, 4, 5, and 6. That refers to the cluster. The top square on the top left-hand corner of each of the green squares refers to the next cluster in which that file continues in. I'll demonstrate that in the next slide. As you can see in this example, Memo 1, a size of 21,000 bytes plus, is listed in the root directory as starting in cluster number 2. So we go to cluster number 2. In there, as we take a look at the top left-hand corner, it'll reference the next cluster that contains data associated with this file. Thus, it's pointing us to number 4. So we jump across to the number 4 cluster block in the FAT table. And we look up to the top left-hand side again, and we see that it's now referencing us to the next table, which would be number 6. And we jump to number 6. And that references us to number 9, and so we jump to number 9. That references us to 10. We jump to 10, and so on until the total size of the data that we recovered is equal to or larger than the size of the file itself. As you can see in cluster number 21, we have an end of file marker. That means this is where the file ended. And when we add up each one of those blocks, it will be equal to or just slightly larger than the original size of the file. So, recovering erased files. Let's start off with a DOS command. We'll type in delete memo 1. What really happens when we delete memo 1 or we hit the delete key and it on the file name memo 1? The first thing that happens when we're deleting a file in a DOS operating environment, the DOS operating system changes the first character to a sigma sign. This notifies the operating system in the future that this specific root directory entry is available to be replaced by a brand new file name. The second step in what DOS does in deleting a file is it remembers where the starting cluster was. As in Memo 1, the starting cluster was cluster number 2. So the FAT table goes to sector cluster number 2 on the FAT table and zeroes it out, essentially making the size of the file 0 in length. At this point, I guess we should review what a cluster is in regards to a FAT table and a FAT operating system. A cluster is nothing more than the continuous group of sectors on a disk, the physical sectors on a disk, and they refer to a group of them as a cluster. In this example, cluster 200 are sectors 1 through 4. Cluster 201 would be sectors 5 through 8. So when we refer to a cluster in the FAT table, it will actually refer to multiple sectors. And this can vary based on the size of the partition that we're looking at, or the disk. Sometimes you will have 4 sectors per cluster. You can have 32 sectors per cluster. That will all be determined by how big the partition is, which is read at the beginning of the boot sequence when we're booting up on a hard drive. The next item that the DOS operating system will do is zero out the rest of the links in the chain. Right before it erased the next link, the pointer in cluster number 2, it recorded that the next pointer was number 4. So then it jumps to number 4, sees that that cluster refers to cluster number 6 next. It then zeroes out the pointer in number 4 and jumps to number 6. It will repeat that process all throughout the chain that we had originally set up until it finally reaches cluster number 21, where it erases the end of file marker and again places a 0 to zero out the entire length of the file. At this point in time, Memo 1 is now erased. The root directory entry has been erased and is ready to be replaced with the next new file that is created. And all the links in the FAT table now are showing 0, which means that those clusters are available to be allocated to a new file when it is created. Seems pretty easy to erase a file, doesn't it? Of course, this is the DOS operating system, which is the basic and the easiest to do that in. So now our goal is to unerase the file, in which we just erased with a delete command. How is that done based on the information that we have at hand? Recovering erased files. Now that we've erased the file, let's see what it takes to go back in and recover it. What do we know at this time? Well, we know that the original file, Memo 1, had its first letter replaced with a sigma character, indicating this was free and open to use at this directory entry. In all reality, if we were looking at this from a brand new standpoint, we would not know what that first letter is. All we know is that the rest of the file name was EMO1. However, we do know that the file was 21,636 bytes long. The delete process did not delete that piece of data within the directory table. We also know that the file itself started at cluster number 2 in the FAT table. That piece of information was not erased. So now to find out how many clusters are actually taken up by this file, we take the size of the file, 21,636, divided by our cluster size, which we will know from the boot sector as to how many bytes are in a cluster, and it comes out to 10.5 clusters. We actually round that up into 11 clusters in total. So now we know where the file started, how long it is, and how many clusters are used up by that file. To start off the recovery, the first thing we do is change the first character, which is now a sigma, to any other valid ASCII character. Anything through A through Z, 1 through 0, and then some of the specialized characters. But generally, it has to be a valid ASCII character. The next step we do is note what cluster the file starts in. Because that was not erased in our original erasing, we know that it started in cluster number 2. We now go to that cluster in the FAT table. If it's available, that means no one else has claimed it, or not another file had already claimed that portion of the FAT table, we now know that this file has the ability to be recovered. All we need is 10 more clusters, and we search for the next available 0. So we'll mark cluster number 2 with the next open cluster that we can find, which in this table happens to be at cluster number 4. So in the FAT table entry for number 2, we will write a 4. As you can see here, we found that next available entry, and we went back and marked entry number 2 with a 4. So as a computer will look at this directory entry, it'll start off at cluster number 2, see that it's pointing to number 4, and jump to number 4. We continue the search for available clusters and place the pointers in those available clusters to the next available cluster until we reached a total of 11 clusters. At that point, on that 11th cluster, we will mark that with an in the file marker. The possibility that this file is the completed erased file again is high. A lot of things can change that, such as how old the file was when it was erased. Were other files created and their data written in those clusters? Everything will vary depending upon how long the operating system was running and how many files were created or deleted in between the recovery of the deleted file, between the time the file was originally deleted and that you are now recovering it. You would think at first that the possibility of this would be really low, but in all reality, statistical odds show that it's very likely that you can recover a lot of the files and in their original state. But there will be those times where you could be recovering a file and the file itself may be portions of it part of the original file, but other portions could include data that came from a file that had at one time been allocated the same space and overwrote the original data in that space. And that's the one important part of this that I have not mentioned to date. When we erase files in the DOS operating system, the only items that are erased, that first character of the file name and the pointing cluster numbers within the FAT table. The actual data on the drive is not changed. The actual size of the file is not changed. Or most of the file name is not changed or deleted. That's important to know. That would be like looking at the index of a book. As you open up the index of a book, what's there now is the title of the chapter you want to go to and the page that it's located on. Same thing holds for this drive. The directory shows the file name and where it's located within the hard drive itself. When we erase that, all we're really doing is erasing that first character of the chapter name, but everything else is there. We can actually turn to that page which says it started and read all the data on those pages that are there. That is never touched unless a special program for erasing is used. Now let's get to the more complicated one. Let's erase both files with a DOS command. So we'll take our DOS disk and we'll type in delete m ***, and then we'll try to recover both files. Once again, the first action that occurs is DOS will change the first characters to a sigma sign. The operating system then traces out to the FAT link and sets all the links to 0. Cluster number 2 is 0, number 4 is 0, so on, all the way down to cluster number 21, which is the in the file marker, and that is placed to 0, thus freeing up all these FAT table entries and that space associated with it for any new file that is created. The third step that is done, DOS will change the first character of the second file, memo2, to a sigma also.